circular cone. I have a right circular cone. I will draw it. And I'm told the slant height is 10 centimeters. I know both of them. That's the radius and that's the height. Right? And a right circular cone is that's a right angle. It's your cone as you would understand. What am I asked to do? I'm asked to maximize the volume of this cone. So if you have a slant height of 10, what's the biggest cone you can have with a slant height of 10? That's what the question is. 2, I write down the volume for a cone. It's 1/3 pi r squared h. Can I differentiate that? No. Why? It is in 2 variables. I need now to be able to write one variable in terms of the other. So what information have they given me? The slant height. And from the slant height, I can write what? That L squared is equal to h squared plus r squared, because that's a right angle, right? Angle. 100 is equal to h squared plus r squared. 100 minus h squared is equal to r squared. Now, does anyone know why I picked what r squared is equal to and not what h was equal to? Because I have an r squared there. It was easy. So now I know in 4 that the volume is equal to 1/3 pi r squared h. The volume is 1/3 pi r squared, 100 minus h squared times h, which is 1/3 pi times 100h minus h cubed. Yes? Which is, now, what's the easiest way to differentiate this? As it is there, is that a product rule? No. Why? There's no h in that. So now I could just work out dv dh. It's 1/3 pi times 100h, 100, minus h cubed, 3h squared. I know then that at the stationary point, what do I know about dv dh? It is 0. So 1/3 pi times 100 minus 3h squared is 0. That divides across, so that means 100 minus 3h squared is 0. Do you understand what happened there? I divided by 1/3 pi. What's 0 divided by 1/3 pi? It's 0. So 3h squared is equal to 100. H squared is equal to 100 over 3. H is equal to the square root of 100 over 3. That's probably 10 over root 3 would be the easiest way of writing that. Now I have a plus or minus, of course, because it's the square root. Yeah? So plus or minus, what about the minus? It makes no sense mathematically. Is that all right? Now, I have to prove that that's a maximum, so I must get b2b dh squared, which is 1/3 pi outside it. Differentiate the 100, 0, minus 6h, which is, that's correct. So the 6 will go with that, it's minus 2h. So I know that at h equal to 10 over root 3, where am I gone wrong? Where? 1/3 pi. Differentiate the 100. Minus 2 pi h. At h equal to 10 over 3, it's minus 2 pi by 10 over root 3. That's going to turn out to be what? Negative. So it's less than 0. Therefore, I have what? A maximum. So I'm going to get a maximum the maximum value I get is when the h is equal to 10 over root 3. It didn't ask me to find h, it asked me to find r. I know r squared is equal to 100 minus h to be squared, 100 over 3. R squared is equal to 200 over 3. R is equal to the square root of 200 over 3. Any questions? The differential out? Yes? No. I didn't differentiate to 1/3 pi. I just differentiated that. Just say, for example, I call that u and that's v. The derivative of that will be 0. And the derivative of that will be minus 6h. Yes? So if I call that u dv dx plus v du dx, I would just get the derivative of that by the 1/3 pi. Because the 1/3 pi is a constant, I can just take it outside and differentiate what's there. If that was 1/3 pi h, I would have to have done that how? Product rule, because it would have been a function in h by a function in h. Have you any questions? Now that's easy. I'm now going to do the exact same question. The slant height of a right circular cone is L. L in this case from now is a constant. You're given that it is L, right? You want the formula for the maximum value, right? So this is max. And given a right circular cone, what am I told its slant height is? L. I know that that's h and that's r. But h is given, or L is given. In other words, from now on I will treat L as what? A constant. 1, I'm asked to maximize the volume. 2, I know the volume is 1/3 pi r squared h. 3, I know that L squared is equal to h squared plus r squared. So L squared minus h squared is equal to r squared. And 4, then I know the volume was 1/3 pi r squared h, which is 1/3 pi by the radius to be squared, L squared minus h squared times h. So that's equal to 1/3 pi all over h over outside of L squared h minus h to the cubed. You got that? Is L a variable? No. L is what? And you're asked to find the maximum volume of a cone of slant height what? L. So it's like saying of slant height, what did I tell you in the previous one? 10. Now if I do this, it does the maths only for a cone that is a slant height of what? 10. And if I do this maths, it solves it for every cone. Once you give me what? The slant height, I'll have a formula for it. 4, 5. dv dh is equal to 1/3 pi outside it. Differentiate L squared h. L squared minus 3h squared. I know then 6, I missed one there, that at the stationary point, I know that dv dh is 0. That implies 1/3 pi outside of L squared minus 3h squared is 0. That divides across. L squared minus 3h squared is 0. 3h squared is equal to L squared. H squared is equal to L squared over 3. H is equal to the square root of L squared over 3. H is equal to the square root of L over root 3. H is equal to L over root 3. Now, what have I found out that? Once you give me the slant height, What should the height be to maximize the volume? It should be the slant height divided by what? The square root of 3. That is the value that will give me the maximum volume on any cone if you give me what? The slant height. What would the radius be? Well, I know r squared is equal to L squared minus H squared. What's H squared? L squared over 3. R squared is equal to 3L squared, 2L squared over 3. So R is equal to the square root of 2L squared over 3. That radius and that height will give me what? The maximum volume of what? If you give me the slant height of a right circular cone. Different type of max.